Hey guys, welcome back to the part 2 of our Python OOP series. So, we have talked about the OOPs fundamental. Now, we are going to talk about the core principles of object oriented programming. They are also known as the four pillars of OOP. Alright, so to get started, let's create a file. Python file, we'll name it as principles. So we'll start with encapsulation, where you'll learn about public, protected, and private members and how to use getters and setter methods effectively. Next, we'll move on to abstractions, where you will learn about simplifying complexity by hiding unnecessary details using the abstract class. And then we'll move to inheritance. I have a different session for inheritance in detail, but this will be a brief session on what inheritance is and how you can reuse and extend your code across classes, understand constructor chaining with super, and explore how Python method resolution order works. Okay, also known as MRO. Finally, we'll learn about polymorphism, showing how Python handles a method overriding, duck typing, flexible function arguments with args and keyword args. So I'm hoping that by the end of this video, you'll have a solid grasp of these OOPS concept, and these are very critical when you are writing scalable and maintainable Python code. Okay, so let's get started. So I'll try to cover more theory on the theory slide or the summary session that we have. Right now, we'll just take examples and we'll explore how we can uh, demonstrate encapsulation in Python. So encapsulation at its core means a group related variables and method inside a class and control how the data is accessed and modified. Okay, that's the core meaning. In simpler word, it's about protecting the internal state of your object, and this isn't about like security or password. It's about code clarity, consistency, and preventing accidents. So let's take a real world example of car that we were looking earlier. So you think of a car, you are the driver. You don't need to know the physics of how transmission works, right? You press the accelerator, the car moves forward. You don't directly touch the gears. The car is designed in such a way that it's going to handle it within its own engine, right? So that's the concept of encapsulation. The complex part are hidden away. Okay, you are just given a clean and controlled interface like steering wheel, pedal, buttons, brakes. So you hit that, there is a certain command that is passed from you, and the system behaves in a certain way. So all those behaviors are written somewhere inside your code. You just have an interface to interact. Now, why do we need encapsulation? In our car example, without encapsulation, anyone can directly change the sensitive properties like speed or the fuel level, maybe even set the fuel to a negative number. So, what encapsulation gives us is a controlled access, validation before changing any data, and which results to very fewer bugs and easily debuggable code. One thing to understand here is Python doesn't enforce strict access control like Java or C++, okay, but it gives us naming convention to indicate the access levels. So we have three different access modifiers. They are public, private, and protected. Now let's see how to define each of those. Let's do it inside a class. Let's take class and same car. We'll take init def national underscore init underscore, and I'll just take the self keyword, no parameter. How do you define public? Public is simple, self dot brand, okay, is equals to Toyota. What is this? This is my public declaration. So this is access to any of the methods or any of the calling objects of this class. Okay. Now next comes self dot underscore, and we'll say a variable name, say engine status is equals to, I'll set it as off. Now since we have given one underscore in front of my variable name, this is classified as protected. Okay. And similarly self dot underscore serial id, and I'll give it as a b. So this is my serial number. So how and this is classified as private. Now what each of these declaration means? The first one is public, so you can read and change it freely. There's no restriction on it. When you declared it as protected, it is treated as internal. Okay, and you have to use it with care. Okay, when you declare it as private, Python will try to remove the access level, or it will not allow you to access this variable directly. So what Python will do, it will mangle the name to discourage direct access to this variable. Okay, but there are ways you can access this variable. We'll see this in the later video. Let's move on and let's see what are getter and setter methods. Okay, so right now we have just declared a variable. So I'm not going to change my brand Toyota because this I can modify anyways. So for the next two, for the protected and private, I'm going to write getter and setter method. Okay, how do you do that? You'll say def and you'll say set underscore engine status, and you'll expect a status inside it, right? You'll say self dot engine status and you will assign the value to it. All right. Now the next thing to do is getting the status. So these function, what these will do, instead of directly accessing those variables, you will use a getter and setter method to assign values and again read the values of those particular variables. So what are these? These are attributes and these are methods. All right. As since we are using class concept, we are going to refer it as attribute and methods. All right. Now next thing we want to do is we want to do the same thing for our serial ID as well. So we'll say define set underscore serial ID, and we'll take the serial ID, we'll assign the serial ID to the object instance, and then we'll say define get serial ID and we'll just print it. Okay, or just return it. We have written the getter and setter method for my protected and private variable. Now how do you use it? So to use these, you have to have an object created for the class. So we'll say car is equals to car, and you'll say get engine status print car dot set engine status. From this I can set it as on now. Okay, and again I'll say get the engine status to check whether it is successfully changed or not. All right, similarly I'm going to change my serial ID as well. I'll say print car dot set serial ID, and I'll set the ID as test data. So this is a dummy serial ID that I'm passing right now. Okay, and then I'll say get serial ID. Now I don't need these print statement because this is not going to return me anything, right? I'm just setting the variable. All right, let's run this. What do we get? So if you see, the first time my engine status returned as false, I changed it and my engine status is on now. Then I changed my serial ID, which was assigned to this value, and I changed it to a test data value here. All right. Now, let's say you have a certain way that your serial ID should be. Say you want it to be 7 characters long or it should be alphanumeric. We want to have a check here for let's say 7-digit alphanumeric or 7-digit string. So we cannot pass a list value or any other different data type, not just number, or we cannot leave it blank as well. Okay. So if that's the case, then by default, whatever number is generated here will be assigned to that particular object instance. Okay. How do we do that? So while you are setting the variable, so you need to check here. Let's say if is instance serial ID, and instead of int I'll check it for string. So what I'm doing here is if my serial ID that I'm receiving is string type and length of serial ID is less than, or let's say I want exact 7 digits, is equals to 7, then only you are going to set my serial ID, else invalid serial ID. Okay, clear? Now let's see what happens. Let's run the same example. Now, since you passed just a string data, but this is of 8 characters length, so it threw you an error, invalid serial ID, and it printed the original serial ID that was assigned inside my class. In this example itself, let's see what is name mangling in Python. So when you declare a variable here, when you have declared a variable here as private, right, underscore serial ID, right, so it becomes inaccessible outside the class. So that's the kind of privacy that Python has set to a private variable. Okay, it's private to the class, but Python internally changes the name with the class name added as a prefix in the variable name, in the private variable name. All right. So let's see. Let's try to print all three of these variable and see what if we are able to print it or we get an error. All right. So let's print car dot brand, print car dot underscore engine status, print car dot underscore underscore sl underscore id. It's capital or small? How is it declared? Everything is small, right? So if you see, there is a warning already here. Let's see what error we get here. So if I try to run this, I'm getting until here was get serial ID is here. We got Toyota as the brand and we got engine status as on, right, which is set here. Now, when it comes to accessing the private variable, what it threw me an error? It threw me an error saying object has no attribute serial ID and it's giving me a suggestion. Now, since it is a private variable, I will not be able to access with the object reference itself. Okay? I'll have to use a getter and setter method to assign values to it. All right. Now, another way to access this is, however, it is discouraged that you don't access it using a class reference. Like I said, the name mangling technique of Python, if you add underscore and give the class name here, it will still throw you an error. This method is discouraged, but this can be helpful while you are debugging. Now, if you try to run this, what do you get? Now, this time it won't throw you any error. Instead, it will print it. All right. Because Python gives you that flexibility, saying, hey, don't touch this unless you are not sure what you are doing. You can technically access it using this way, but Python also says this is not the way you should be using your private variables. So what is this? This is name mangling. If you have to get the value, you have to use your getter method for serial ID. So, this is how encapsulation works in Python. It uses three techniques or three access modifier: public, protected, and private. At the same time, you have to use getter and setter method for your private variables. Now, it is also important to understand that encapsulation is not about hiding the class in itself. Okay, it's about hiding the implementation details so that we are just exposing what is needed here. So say you wrote this code, this class code you have written. Now someone else has to give an serial ID here. Okay. Now he gives a serial ID with some random numbers, a longer number, maybe a 10 character long string. Okay. Now he should get an error message, right? So that is expected from your code, that if the format or if the length is incorrect, it should throw an error. So those implementation you have done inside your class, and this is not accessible to anyone outside. Okay, he cannot change the implementation level. He just has the getter and setter method. He'll just give the input, check the output. All right. So that's where encapsulation plays a role here. So moving on, we'll see what is abstraction. So abstraction is hiding the complex internal logic and exposing only essential needed to use an object. Let's break down the car analogy again. Okay. So you press the brake, the car stops. Do you know how the hydraulic system works? No. Do you need to know? No. So that's abstraction for you. So abstraction, what it does, it helps you to focus on what matters to the user, hide the messy internal logic, make the code easier to understand, and give a simple interface to the user saying, hey, this, you are going to send me this, you are going to expect this. Internally, what I'm doing is taken care into my abstraction logic. So in simple words, the flexibility that abstraction gives you is by defining what to be done rather than how it is being done, right? So say you are listening to song using a Spotify app. So you're not going and connecting to Spotify app server to check whether my connection was correctly set up or not. You're just hitting a play button and the song plays for you. Everything else is taken care in the background. Let's come back to our car example that we had, and we'll see how abstraction is working there. When we talk about car, we know that every car has an accelerator and a brake. Now, using abstraction, we are going to define accelerate and brake in our car classes. Now, the implementation of the car classes is in such a way that you don't have to define anything inside your class. You just have to give a blueprint on what you have to do. How it is being done will be taken care later. In Python, we have a module called ABC. Okay, this is nothing but abstract base class module. Okay, and we'll use ABC to define an abstract class. Let's see how it is being done. So let's say from ABC import ABC and what else? Abstract method. Why it is not importing? It's not recognizing. Oh, there is a typo here. So from abst abstract method. So we have imported our ABC module. Now we are going to define a class. So my class will be class absolute ABC. Okay, or let's stick to our car class, right? Car, and I'm going to take it, make it an ABC. I'm using the keyword ABC for abstract class. And what next I want to do is I want to create an abstract method. So we have to use an annotation abstract method and define a method. So we'll say define accelerate. All right, I'm not going to do anything. I'll just say pass here. Now I'll take another abstract method. I'll say deaccelerate. What I'm going to do? Nothing. Just say pass. All right. Now this is a basic blueprint of my car. Okay. This defines what a car should do, but not exactly how it should do. You're not going to create any object of this class. That's abstraction in Python, or that's abstraction in general. But instead, you have to implement this class to how the accelerate and brake works. So implementation is, again, you have to define a class electric car, and it implements car. Now inside this car, I'll have to implement all of the method from my abstract abstract class. All right, if I don't do that, Python won't allow me to create an object of this class. Now let's first define my accelerate method, or let's first define my default constructor. Let's say define, we'll say underscore init self, and I'll say brand, and inside this what I'll do, I'll just say self.brand is equals to brand, and since I'm going to accelerate and deaccelerate, I'm going to use another variable called speed. Self.speed is equals to say 0. All right, this is done. Now the next thing I want to do is accelerate. So we'll say define accelerate, and accelerate, every time I hit accelerate, I'll say I'll increase the speed by 5. Okay, so self.speed is plus 5, and I'll say print the car accelerated by speed, and I'll print the message. And similarly, I'll have deaccelerate as well, right? And I'll say self.speed is minus 5 every time I deaccelerate. Okay. Now what happens here? Now once the speed is 0, or let's run this and we'll do the modifications later. I also wanted this brand to be printed, right? The car of brand self dot brand, the car of brand self dot brand. So what this class is doing, it is inheriting from abstract class, that is car, and provides the real behavior to accelerate and brake. Okay. Now let's see how we implement it. All right. So implementing is, again, we have to create an object of my electric car. My electric car is Kia, is equals to electric car, and I'll pass the brand as Kia. Now I'll say accelerate, yeah, dot accelerate. I'll say deaccelerate. I'll again say deaccelerate. I'll again say deaccelerate. So I'm incrementing here by 10 and decrementing by 15, right? So ideally a car's speed cannot be in negative. Let's run this first and we'll talk about that. So what it says, the car of brand Kia accelerated by 5, then it is 10, then it deaccelerated to 5 and 0. And the last deacceleration, it gave me minus. But ideal scenario is not this, right? You cannot have a negative speed. So while deaccelerating, we have to write another, say self dot speed is equals to, we'll say maximum of what? Maximum of 0, comma, and self dot speed minus 5. Okay. So whichever is the maximum, I'm going to return that value. Instead of minus 5, I want 0. All right. So no matter how many times you deaccelerate after this, you won't get any values below 0. Right. So you are continuously hitting the the brake button or the brake pedal of your car. So the car speed will be at 0, right? It cannot go further down to from 0 to minus 60, right? Just because you are holding the brake. All right. So let's run this. Right. So it came to 5, 0, 0, 0, 0, 0. Now, when you are dealing with abstract class, it's important that you do not have to instantiate your abstract class. You will get a type error there. Okay. Or if you want, let's do this. So let's say you have this car, and I'll say my car is equals to car BMV, and we'll say car dot accelerate. Okay, let's run this. What happens? So it says car, oh, takes no argument. Let's run this. What it says, can't instantiate abstract class car without an implementation for abstract methods. All right, because it doesn't have any implementation here. This is my abstract class. I cannot instantiate this class. All right. And it's also important, while you are implementing these methods, you have to define all of the methods that you have used here in your abstract class. If you're not going to use all of them, it's again going to throw you an error. So let's remove one of these, or let's just comment it, and we'll try to run it. We'll remove this code from here. Let's run this. It gives you the same error. Can't instantiate abstract class electric car without an implementation for abstract method deaccelerate. Keep it to how it is. Okay. So what abstract method does is it gives you a blueprint of how you are going to implement, and the implementation is followed in a separate class. So this gives you a blueprint of what you want, and how it is done using an implemented class. Okay. And while implementing, you have to implement all of the methods inside your abstract class. And when you are defining an abstract method, this is another terminology used. So when you are defining on how things are being done from your abstract method, say you in this electric car, you have defined how accelerate and deaccelerate works. So you are giving a meaning to your abstract methods. So these classes are known as concrete classes. Okay, because you are giving the implementation of your abstract class. So these classes are also known as concrete class. All right. So to wrap it up on abstraction and encapsulation. So in abstraction, we had seen we create a skeleton using our abstract class and method, and my Python won't allow me to create an object of my child class if I don't implement all of the abstract methods. Why do we need abstraction? Abstraction is needed to hide all the detailing, or to hide all the mess inside my code. We define a skeleton using that interface, and my child class fills in all the details. Okay. Python uses ABC module and a decorator at the rate abstract methods. All right. While in encapsulation, we had seen encapsulation is not about hiding the class itself, it's about hiding the implementation details by exposing only what is needed. And how did we do it? Using three keywords: public, protected, and private. Public is just a variable name, protected is with an underscore, private is two underscores prefixed. Now, where do we use or what is the use case of encapsulation? It's used where you have your sensitive data or your logic should not be tampered with shared code bases, and where you have a growing classes that other developers or other testers or QA engineers are going to use. All right, so you have to implement your code in such a way that you are only exposing a limited data what this or the other system should be seeing. Okay. All right, so I'm going to wrap it up here. In the next one, we are going to talk about the basics of inheritance, and we'll see what polymorphism is. All right, thanks for joining, guys. Bye.